Hello there guys and welcome back to another epic next rule maths video. We're looking very sinister today. There's dramatic lighting going on. It's just because it is dark. That is the reason. So yeah, my lighting setup's very cinematic, mysterious even. But yeah, so in this video we're taking a look at how we might go about deriving the formula for changing the base of a logarithm. I've written down what the formula is right here. If you have any logarithm base b of some argument a, that is always the same thing as the logarithm base c of a over logarithm base c of b. And the beauty of this is c can be whatever you want it to be. So you can have c equals 2, 3, 4, whatever you need to solve your problem. That's what c can be. You invent c. You can choose what it is. It actually doesn't change anything. So for example, if you had the logarithm base 2 of 5, let's do that. Let's just do a quick example just to exemplify what I'm saying. The logarithm base 2 of, let's say, 5, right? That is going to be equal to, and so b is our 2 and 5 is our a. So this is the logarithm, and let's make up a base. It doesn't matter what the base is. Let's say log base 10, doesn't really matter. Log base 10 of a, so a is 5, divided by log base, and we have to use 10 again because 10 is going to be our c, but it doesn't have to be 10, that's the beauty. It doesn't have to be 10, it can be whatever you want, over b, which is 2. So actually we get that these are the same thing. And in fact, here's the really cool thing. That 10, like we could just say 9, we could just put 9s there. Or we could put 8s there, or 7s, or 100s. Doesn't matter, it's always true. It's always true as long as they're the same number, right? So that's the idea behind the change of base formula for logarithms. I will also make another video on this topic in the future because this is incredibly important because it lets you differentiate logarithms of any base. And we'll do another video on that. In this video, we're just deriving the formula. So let's just jump straight into it. How do we derive this thing? Okay, so what we're going to do is we're going to start off with inventing some new variable. We're going to call it y. We're going to say that y is equal to the logarithm base b of a, right? We want to know basically, can we rewrite y in a different way? So we're saying we're going to start off with some logarithm base b of a. Brilliant. Okay, now what we're going to do is we're basically going to use log rules to just kind of move stuff around, right? Turn this into an exponential equation. How do you do that? Well, you simply say, okay, base to the answer equals a, okay? So if you're not familiar with this, no worries, but you do end up getting that b to the y equals a. That's how a logarithm works. That's basically the definition of how a logarithm works. This is the same equation. It gives you the same line or curve when you plot it. It's just rewriting the equation basically. So hopefully we're happy with that. That's fine. So this is the same equation. We've just rearranged it. I know it looks kind of weird, but that is true. We have just rearranged it. So we get b to the y equals a. I hope everyone's happy with that by definition. Okay, now what we can do is we can take logarithms on both sides, but it doesn't matter what the base is. So again, we're going to use base c, where c can be any number that you want. And what we get is that the logarithm base c, where c doesn't matter what it is, of b to the y is equal to the logarithm base c of a. Beware guys, sometimes my g's look like lowercase y's, so just beware. Okay, we get this formula. Now, what we can do with, it's not a formula, it's an equation. What we can do with this equation is we can use the power rule for logarithms to bring that power down and multiply it by the logarithm. So what we can do is we can rewrite this again and we can say y multiplied by log base c of just b, because the y has come down to the front, is equal to the logarithm base c of a, just like that, okay? Just rearranging. Now, the whole idea of this is, remember what y is. We want to make y the subject and see what it's equal to. So how do we make y the subject? We simply divide both sides by log base c of b. And therefore we get y is equal to log base c of a divided by log base c of b, just like that. And that actually is the change of base formula. All we need to do is substitute our y back in. What did we say y was originally, guys? What was the value of y? It was log base b of a, of course. And what this basically means is if you replace your y back again with log base b of a, you get that that's the same thing as we can even use a 3 lines identity symbol there to really show they are truly always the same. This is equal to the log base c of a divided by the log base c of b. Just like that. Once again, c can be whatever you want. This is an absolutely fascinating result. This is the change of base formula. And for example, one thing that's really helpful that we can do, and this will lead on to a future video that I'm doing about differentiation, if you let c be equal to e, not the letter e, the number, so 2.1 and 2.71 and so on, that is Euler's number. That is the base of the natural logarithm. It means that the log base b of a is always identical to the natural log of a over the natural log of b. It doesn't matter what a and b are. Of course, they have to abide by the rules of logarithms, so there are restrictions on what a and b are allowed to be. But in general, that's how it works. So for example, log base 2 of 5 is simply going to be equal to natural log of 5 over the natural log of 2, because that's your a and b in that example. And that's really useful, and that will lead on to another video. If you guys enjoyed this one though, thank you so much for watching. I highly appreciate it. Share with your friends, family, loved ones. Christmas is approaching, so maybe this will be their present. And I'll see you in the next video. Cheers.